Hi, Kelly from Opto 22 here. Have you ever wondered how, when you call your mom on the telephone, the signal travels between your phone and hers? In the old days, switch operators would manually connect your phone line so your voice could travel over the correct circuit. Now, all switching is done electronically in central offices, where hundreds of lines are switched every second. With telephones being everywhere, these central offices, or COs, are everywhere as well. In fact, you've probably even driven by one, but you may not have noticed because the building can be very nondescript. Today I'm standing in front of the central office for Verizon Communications, one of the world's largest communication companies. A few years ago, they designed and implemented the next generation CO, and they've invited us here today to take a tour of it. I'm now sitting with Don Nitsch from Verizon, who's going to talk to us today about the Garden City office. Don, can you tell us a little bit about yourself and what you do?
I'm senior engineer for Verizon Power in New York State. I'm on special projects, and this is one of my projects.
Okay, so modern telephone companies use electrical switching because you can connect and disconnect many lines at any given moment. Are there any downfalls to doing switching this way?
Computers are very small equipment. They're confined into small areas. They produce a tremendous amount of heat. We have to cool equipment. If the equipment exceeds 100 degrees, it starts to fail. We are in a life-saving business as much as the ambulance, fire, doctors, because they have to communicate through our network. We cannot have downtime. If we have downtime, communications doesn't happen. Verizon is the biggest energy user in the state of New York. Probably the telephone companies throughout the United States are the biggest single energy user. In this facility, we had a goal to go green, to reduce our energy costs, reduce our pollution costs.
So a few years ago, Verizon decided to address some of these issues with a new prototype. Can you kind of explain this prototype?
They started a project with fuel cells to reduce our energy costs, reduce our electric, and the fuel cells were a cogen project that converts natural gas into electricity. So basically, we are using steam power, hot water, to drive mechanical equipment, and that does produce the chilling. The major benefit is reduced emissions. Our boilers aren't running nearly as often because the fuel cells are producing hot water, and we're drawing less power off the grid. So we're reducing the amount of fossil fuels that the utility has to use to produce electricity for us.
The success of this prototype really depends on the reliability of the monitoring system. To implement this monitoring system, Verizon turned to Breen Interface, who has over 16 years of experience implementing control and monitoring systems.
We got involved with Verizon after the 2003 blackout because Verizon decided to better monitor and control their power systems. My name is Eric Breen. I'm the owner and president of Breen Interface Corporation. We're a systems integrator. We monitor large-scale, high-reliability power systems. We're using the Opto 22 Snap.io series product line, primarily with PAC R2 brains. We interface it to everything affecting the power, starting with monitoring the utility power that comes into the building, the generator power that's produced by the generator when it's running. We monitor the fuel tanks. Then we monitor the transition of power, whether the transfer switches are opened or closed, whether the circuit breakers are in the normal position or the emergency position. And then we monitor the health of the battery plants also for the equipment that's providing the actual power to the service generating equipment. We used Verizon's operations support network to transmit all the alarms. The beautiful thing was this wonderful network existed between all of the buildings already, and we wanted to use that to transmit the alarms. We used Unicenter, which is a software product that's normally intended to monitor IT equipment like printers and servers. We use the power of Unicenter and the alarm reception capabilities of Unicenter in Verizon's environment to receive alarms from power-related devices, non-IT stuff, machinery. In other words, we'll send alarms when a fuel level drops low in a fuel tank, the same way Unicenter would receive an alarm from a printer that ran out of paper. So by using Unicenter at the data center and using the Opto equipment connected to the network in the remote buildings, it enabled us to put the whole picture together. This is one of the switchgear bays. We have a Opto 22 16-module rack in there with a variety of different module types. This rack is monitoring the health and switch positions, everything to do with the generator in the other room. We have a simple I/O unit. This is a serial input module here that's doing double duty, the 2 ports on it. One port is talking to the panel instrument here. The other one is talking to the Caterpillar customer communications module. And then we have various digital input modules. We're monitoring the temperatures in the generator room, as well as the intake air temperature to the engine's cooling system. And then we have digital output modules. We have the ability to remotely control the engine. We basically just had to clip in the modules that we needed to acquire the signals that were here. When we looked at selecting the hardware, we realized our application had a lot of serial data feeds, had a lot of different signal types. We used the Opto 22 systems because of the flexibility it offered with providing a module for each data type without buying anything extra. And we had the power of programming drivers ourselves to work with the various serial protocols that were available. So it gave us a lot more flexibility, both programming-wise and hardware-wise, than any other PLC would have given us.
I like the system because it's actually reduced my expenditures. This has been a relatively trouble-free system. We can use Opto by switching from screen to screen, from building to building, no dial-ups, one control center. That was a big benefit to us. During the blackout, we had one control center in Manhattan. And you can't get to that control center during a blackout. There is no subways, no buses. Forget about traveling. We can have all the experts looking at the screen, looking at the same data from 10 different rooms or 10 different states or any place in the world.
Well, thank you so much for sitting down with us today and showing us your central office. And thank you guys for watching this video. If you'd like more information about this application or other applications, check out Opto 22's website. Have a great day.